Right now, underneath the deserts of East Africa, the ground is quietly tearing itself apart, and researchers just discovered it's happening considerably faster than anyone previously believed. This isn't a distant, hypothetical scenario buried in a textbook somewhere. Scientists have found direct evidence of new ocean crust already forming. Beneath the surface, Africa is genuinely splitting in two, and the process is moving faster than the models predicted. Let's start with the basic geography of what's actually cracking apart, because the scale of this fracture is almost impossible to picture using everyday reference points. The East African Rift System stretches more than 3,000 kilometers, running from the Red Sea all the way down through Ethiopia, Kenya, and Tanzania, continuing toward Mozambique. At the heart of this system sits a location called the Afar Triangle in Ethiopia, one of the hottest, most inhospitable places on the entire planet, and also, geologically speaking, one of the most fascinating. Afar sits at the exact meeting point of three tectonic plates, the Nubian, the Somali, and the Arabian, all three gradually pulling away from one another in what geologists call a triple junction. This isn't some slow theoretical process locked away in computer models either. Back in 2005, a crack roughly 35 miles long tore open across the Ethiopian desert within a matter of days, catching even seasoned geologists off guard with how suddenly it appeared. That event offered a rare, visible glimpse of a process that normally unfolds far too slowly for humans to witness directly, and it helped kick off a wave of intense scientific interest in exactly how fast this rift is actually progressing. Researchers studying the Afar region have specifically noted that it remains the only place on Earth where scientists can directly observe a continental rift in the process of transitioning into a genuine oceanic rift, offering a kind of natural laboratory, unlike anywhere else on the planet. Understanding how this particular rift fits into Earth's much longer tectonic history helps explain why scientists find it so significant. New analysis of magnetic data originally collected back in the late 1960s suggests that Africa and Arabia actually pulled apart first, along a single connected fracture, before the separate rifting that eventually produced both the Gulf of Aden and the Red Sea. The African rift itself followed some time after, likely torn open by what geologists describe as a superplume upwelling, an enormous surge of hot material rising from deep within the Earth's mantle, and it has remained continuously active ever since. That deep historical continuity is part of why researchers treat the current phase of rifting not as an isolated novel event, but as the latest chapter in a tectonic story that's been unfolding continuously for tens of millions of years. The newest research, published this year in the journal Nature Communications, focused specifically on a 500-kilometer wide stretch called the Turkana Rift, spanning the border region between Kenya and Ethiopia. Using seismic data to measure crust thickness directly, researchers discovered something that genuinely surprised them. At the center of that rift, the Earth's crust has thinned down to roughly 13 kilometers, dramatically less than the 35 kilometers of crust found in more stable regions nearby. Some measurements put that thinning even more dramatically, describing crust roughly 8 miles thick at the rift's center compared to more than 22 miles thick just a short distance away. That extreme thinning matters enormously to geologists because it represents a very specific, recognizable stage in the process of continental breakup, something scientists call necking. Picture the Earth's crust being stretched like a piece of taffy, gradually pulled thinner and thinner in the middle as the surrounding plates drag apart in opposite directions. Necking represents one of the final stages before a rift transitions from simply stretching land to genuinely rupturing it, eventually thin enough that magma from deep within the Earth begins pushing directly through, creating entirely new oceanic crust exactly where continental crust used to be. According to the research team, this necking process in the Turkana Rift likely began around 4 million years ago, arriving in the aftermath of widespread volcanic eruptions that reshaped much of the surrounding landscape across the region. As one of the study's lead researchers, Christian Rowan, a geoscientist at Columbia University, put it plainly, the rifting happening in this specific zone is considerably more advanced and the crust considerably thinner than anyone had previously recognized. Eastern Africa, in his words, has progressed further into the rifting process than scientists had assumed. So what does the actual end game of this process eventually look like? According to researchers studying the region, once the rift valley connecting these separating plates dips low enough, seawater from the Gulf of Aden and the Red Sea will eventually rush in to fill the gap, forming an entirely new ocean basin between the diverging plates. Marine geophysicist Ken MacDonald, professor, described that eventual outcome vividly, explaining that the Gulf of Aden and Red Sea will flood over the Afar region and directly into the East African Rift Valley, giving rise to a genuinely new ocean. But once that happens, This stretch of eastern Africa, including portions of Ethiopia, Kenya, and Tanzania, would separate entirely from the rest of the continent, becoming its own standalone landmass, roughly comparable in scale to the island of Madagascar. Here's where the timeline genuinely matters, because it's easy for headlines to blur the difference between something happening right now and something that's merely underway on a geological clock. The complete breakup of the African continent is still expected to take somewhere between 5 and 10 million years to fully complete. That's an almost incomprehensible span of time by any human measure, but it's genuinely fast by geological standards. And researchers are increasingly finding that early, visible signs of this eventual split are already showing up today, not merely predicted for some distant future. Those visible signs include measurable ground movement tracked using high-precision GPS and satellite radar technology, tools sensitive enough to detect shifts at the millimeter scale. The Turkana Rift is currently drifting apart at a rate of roughly 4.7 millimeters per year, a pace that sounds almost negligible on a human timescale but represents genuinely rapid movement in geological terms. For decades, this entire rift system was categorized by scientists as slow-moving and comparatively stable. That characterization is actively changing as these increasingly precise measurement tools reveal a considerably more dynamic, faster evolving picture than earlier generations of researchers had access to. The consequences of that ongoing movement are already visible on the ground today, well before any ocean actually arrives. Roads across the region have cracked and split apart. Farmland has been pulled in opposing directions, disrupting agriculture for communities who depend on that land for their livelihoods. These aren't hypothetical future consequences, they're present-day disruptions playing out for people currently living directly on top of an active, widening tectonic boundary. Infrastructure planners and local governments across affected regions of Kenya and Ethiopia increasingly have to factor active ground deformation into decisions about where to build roads, pipelines, and permanent settlements, a genuinely unusual planning consideration, compared to most regions of the world where the ground beneath a community can generally be treated as fixed and stable. If you're finding this kind of deep dive into genuinely fascinating deep earth science valuable, go ahead and hit that like button. It makes a real difference, helping this channel reach more people who want to understand these incredible, slow-motion planetary processes instead of just scrolling past a dramatic headline with no context behind it. There's also a genuinely compelling scientific mystery layered underneath all of this, involving exactly what's driving the entire rifting process from deep within the Earth. Research published last year in the journal Nature Geoscience suggested that the mantle beneath the Afar region isn't uniform or stationary the way scientists once assumed. It actually pulses, sending distinct surges of partially molten rock upward in a rhythmic, almost heartbeat-like pattern. Lead researcher Emma Watts explained that these ascending pulses carry distinct chemical signatures and that the rifting plates above appear to channel and direct that upwelling material as it rises, revealing a genuinely intricate, dynamic interaction between what's happening deep in Earth's interior and what's visible on the surface above it. Geophysicist D. Sarah Stamps from Virginia Tech has noted that the rate of extension across this rift system varies considerably. Along its length, running fastest in the north, that means new ocean basins are expected to begin forming there first, likely near the Afar region and the Gulf of Aden, before the process eventually extends further south through Kenya and Tanzania over the following millions of years. That geographic sequencing matters, because it means different communities across the rift will experience the earliest visible consequences of this breakup at very different points in the coming millennia, even though every stretch of the rift is technically part of the same continuous tectonic process. There's also a genuinely unexpected scientific bonus tied to all of this geological upheaval, one connected directly to human origins. The Turkana region sits at the heart of one of the richest early hominin fossil records anywhere on the planet, and researchers studying this new rifting data have proposed that the same tectonic forces splitting the land apart may also explain why fossils have preserved so exceptionally well there. Rather than Turkana being uniquely important to early human evolution itself, the active rifting and resulting sedimentation patterns may simply have created unusually favorable conditions for preserving fossils that existed just as commonly elsewhere across the continent, information that might otherwise have been lost entirely to time. Researchers found that sedimentation rates in the region increased notably around 4.6 million years ago, coinciding closely with the same period when the necking process is believed to have begun, suggesting these two seemingly separate stories, human origins and continental breakup, may actually share a single underlying geological cause. At the end of the day, what makes this research genuinely remarkable isn't that Africa is splitting apart. Geologists have understood that basic process for decades. What's remarkable is how much more advanced and how much more visible in real time that process has turned out to be. A rift, once considered slow and comparatively stable, is now understood to be actively necking toward genuine continental rupture, with measurable crust thinning, ongoing millimeter-scale movement, and surface disruption all happening today, layered on top of a deep, pulsing mantle. Process scientists are only just beginning to fully understand. The new ocean itself remains millions of years away, but the geological machinery required to eventually create it is already, unmistakably, running. It's worth putting this timeline in perspective one more time before we close, because the scale genuinely defies normal human intuition. 5 to 10 million years sound simultaneously enormous and, in geological terms, almost immediate. Modern humans have existed for roughly 300,000 years, meaning this entire split will likely complete somewhere between 15 and 30 times further into the future than our species has existed in the past. And yet, remarkably, scientists studying this rift today can already point to specific, measurable evidence, thinning crust, drifting GPS coordinates, cracking roads, and pulsing mantle plumes, that the process isn't some distant abstraction at all. It's an active, ongoing transformation, unfolding in extreme slow motion directly beneath the feet of millions of people living across East Africa right now. If you want to keep tracking exactly how this ancient, ongoing process continues developing, along with the real research behind every Deep Earth headline before it becomes tomorrow's viral clip, subscribe to the channel so you never miss an update. Stay curious, stay fascinated, and I'll see you in the next one, ready to explore whatever the planet decides to reveal about itself next.